So here we are, classwork 10. I'm going to load up a little bit. There we go. So I'm going to talk about this, but I'm not going to be able to draw. So this computer won't permit me to draw. So we're a little on-screen keyword. So I'm not going to have my full options here. So with this one, both 81 c squared and 100 are perfect squares. So when you see that, you're always going to have this pattern of the square root of each one. So the square root of 81 is 9. The square root of c squared is c. The square root of 100 is 10. And then you'll have one that's positive and one that's negative. So if we were to multiply these back together, we would get this answer. And it's difficult to show without the box, but this is sort of what they want us to, the pattern they want us to look at. So I'm going to use their little walkthrough here to try to explain what's happening. So see how they're showing the pattern? They say the first term squared minus the second term squared. If you have two perfect squares, then they break down. So the square root of a squared is a. The square root of b squared is b, and so one's plus, one's minus. So they really just want you to memorize this pattern. That's true when you have two perfect squares. So you have to be able to recognize if they're perfect squares, and that can be difficult. So it really helps to have a multiplication table to look for perfect squares. So I'll just keep going. But at this point, we're just doing pattern recognition. Okay. So the square root of 121 is 11. The square root of m squared is m. So we have 11m plus 3 and 11m minus 3. So that's what's going on here. I'm sorry for the slow loading. Internet's being used. All right, next question. So these will go pretty quickly. This one is a little bit different because it's called a difference of squares. Here's another difference of squares. So I'm going to go through this quickly now. So we'll have a 3x plus 7 and a 3x minus 7. And whether you put the negative first or second doesn't matter. One needs to be positive, one needs to be negative. Okay, on to the third one. Maybe. And this internet is killing me. I zoomed out in hopes that I get a display here. This says similar question, but I don't want a similar question. I want the next one. There we go. Next one. So this one's a little bit different, and I'll explain. Zoom in a little bit to see the numbers more easily. So we have to think of two numbers that multiply to 63 and add to 16. So we're still going to have the x plus something, and then we're going to have another x plus something. And I know that because the product is positive. In other words, two numbers that multiplied together is positive. And then those same numbers that multiplied to 63 are going to add to 16. And in order to multiply to a positive number, they either both have to be positive or they both have to be negative. However, if only one is negative, then this will become negative. So the product will be negative. So I know the sum is either from two positives and two negatives. If it was two negatives, this 16 would be negative. If you add negatives together, they become more negative. So I know they have to both be positive. So two numbers that multiply to 63. So I'm going to start thinking of numbers that multiply to 63. The most common one that people reference is 9 and 7, because when people learn multiplication tables, that tends to be a common problem. So I'll use my arrow keys to navigate. And so it doesn't matter which ones you put in which order, but 9 and 7 multiply to 63, and they add to 16. And again, it's really helpful to have a multiplication table. If if you don't have a multiplication table, the other thing that's useful to do is create a factor tree to break down the 63. And if I could draw, I would show you. But you could divide it by 3, and then you'd get 21. And then 21 divided by 3 is 7. So you have 2 3s and a 7 to play with. So you can piece them together however you want, but our goal is to create two factors that multiply to 63 but add to 16. And 7 and 9 are those two factors. So we'll do a few more of these. Hopefully it starts to make sense. And you can always check your work by distribution. So you can multiply, when you have two factors, you can multiply them back together. So this one's already been done halfway for us. X plus 7. So we know that 7 times some number gave us 77. So if we divide this 77 by 7, we get the answer, which is 11 in this case. And sure enough, if we add these two together, 7 plus 11, we get 18. So again, a very important skill. It takes a little while to get the hang of it, but once it's kind of solidified, this skill becomes easy to execute, at least with small numbers like these. So with this one, two numbers that multiply to 12 but add to 7. So 2 and 6 multiply to 12, but they add to 8, not 7. 1 and 12 multiply to 12, but they add to 13. So we want 3 and 4. 3 and 4 multiply to 12 and add to 7. So if we look at the question help, or the view and example, it'll show you how to come up with a bunch of lists of stuff. So this one's 48, and so let me zoom out a little bit. So if you see they come, oh man, I'll zoom out a little further. It's kind of, let me reopen that. They messed up the window size. There we go. So in this one with 48, we're trying to think of two items that multiply to 48 and add to 19. So identify a pair of factors of 48 that have a sum of 19. And so here they just list out all the things they can think of. This is one way to do it. It can be difficult though. It's better to create a factor tree in my opinion. This is fine though, if this is more comfortable. But a factor tree systematically breaks down a number into its prime factors. So this one would be 3 and 16. That would be pretty hard to find without a factor tree. Most people don't know that 3 times 16 is 48. So it's good to make a factor tree. Moving forward at the pace of the internet. So this one again, two numbers are multiplied to 99. Anytime I see two numbers, I think of something times 11. It's like 9 times 11. And 9 and 11 do add up to 20, so those are going to be our answers. And again, a multiplication table would also help you identify 9 and 11 pretty quickly. So it might be worth it to take some time to create a multiplication table. Or to just download and print one. Working on getting a printer. Hopefully I'll have a printer. So this one's a little trickier, and I'll explain. This one thing to look out for, they're using n instead of x. So that's important to make sure that we do is use n instead of x. We're still going to have two binomials, but look at this. The 40 is positive. I'm going to zoom in a little bit. The 40 is positive, but the 13 is negative. That means that both of these terms, both of these binomials, will have a subtraction operation. Okay. So I still want to think of two things that multiply to 40. 4 and 10 come to mind, but 4 and 10 do not add to 13. So 4 and 10 add to 14. So I know it's got to be closer to the numbers being equal. So I'm going to go 5. So 5 and 8. Add, multiply, and again a multiplication table would help with this. So 5 and 8 or 8 and 5. The order does not matter. So these add to negative 13 and they multiply to positive 40. Negative 8 times negative 5 is positive 40. Negative 8 plus negative 5 is negative 13. So this can be a little bit tricky. Again, a factor tree or multiplication table can be very helpful. Trying to figure out what multiplies by 40 first, always identify the things that can multiply to 40 first. There's infinite things that can add to negative 13, so trying to figure out what adds to negative 13 first is going to be a lot harder. So we narrow our search by looking for what multiplies first. Load the next one. Alright. So again, they're using n, and again, it's going to be two negatives that multiply to a positive because our middle term is negative and our last term is positive. So 42 times 20 comes to mind. So I'm going through a little bit faster. They multiply to 40, add to negative 22. So this one's a little harder, and I'll explain why this is. So these are getting a little bit more complex with the negatives. So we have to think of two things that multiply to negative 32, but one's going to be positive, and one's going to be negative. And I know that because we have a negative product, and the only way you get a negative product is if one's positive and one's negative. If they're both positive, you get a positive product. If they're both negative, you get a positive product. So one has to be negative. Now, the difference is 4. So when I see 32, the first thing I think of is 8 times 4. So they're kind of giving us an easy one. And see how the 4 is positive? That means your larger factor has to be positive. I can't click in there. So the 8 will be positive and the 4 will be negative. So when they add together, so 8 minus 4, 8 plus negative 4, that'll become a positive 4. So this one's a little trickier because of that negative. You have to think another dimension. It's not just negatives or positives. You have to think about which one's negative or positive to add up to that 4. Man, it's taking a while. So it should be known I am creating this video when I understand that many of the students are also using the internet. So this is a school internet. Usually I make these videos at home. But lately, this is where I've had time. Okay, so they're helping us out in this one. See, there's a negative 15 here. And one of the factors they're telling us is positive 3. So negative 15 divided by 3 will be negative 5. So x minus 5. We don't have to create the parentheses because they're there for this already. So they're helping us out a little bit with that one. Again, a negative product means that one of them is negative. They tell us the 7 is negative. So negative 77 divided by negative 7 is positive 11. So in other words, negative 7 times 11 gives you negative 77. And these add to positive 4. Is it loading? There it goes. Man, this is some rough internet. Okay, another negative. And this is negative 12. So two things that multiply to 12, and I do these pretty quickly in my head, and I kind of go through them. One's going to be negative. One's going to be positive. So the two things that multiply to 12, 3 and 4, but 3 and 4 don't have a difference of 4. And I know it's a difference because we have a negative product, so there has to be one positive and one negative. So the other thing, another pair of factors that multiply to 12 is 2 and 6. The 6, the larger one, will be negative, so that when you add 2 to it, the result is negative 4. So these will be our factors. Negative 6 times 2 is negative 12. Negative 6 plus 2 is negative 4. All right. Man, that loads slow. Here we are again with 32. Now this one's a little tricky, also with a negative, so one's positive and one's negative. And notice on the last time I put the negative first, it doesn't matter which one you put first as long as the right number is associated with the right, I guess, value, plus or negative, plus or minus. So two things that multiply to 32. Normally I think 8 and 4, but 8 and 4 don't have a difference of 14. So we have to get pretty close to 32. So I have to go the other direction. I have to think of a larger factor. So if I just divide 32 by 2, I get 16. 16 and 2 do have a difference of 14. So the 16, the larger one, is going to be negative. And then we'll add 2 to that. So those multiply to 32, negative 32, and they add to negative 14. Again, it really helps to have a multiplication table to know. Negative 16. So I think 2 and 8 do have a difference of 6, so they will work. So I'll have the 6 is negative, so our larger product or factor needs to be negative. So those will multiply to negative 16, but add to negative 6. And again, you can always check your work by multiplying back through or distributing back through. All right. Oh my goodness. Okay. Again, one positive, one negative, because we have a negative product. So one's going to be positive, one's going to be negative. So 21, I immediately think 7 and 3, those are the only factors of 21, and they do have a difference of 4. However, this time, the larger one has to be positive, because when they add, the result is, the sum is positive. So 7 minus 3, or 7 plus negative 3, you can think of it either way, is positive 4. Okay, I think that's it. I think we're done. It's 15 complete out of 15. So that's this practice. It's important to become quick at this. So it's very important to know your multiplication table pretty well through 12 times 12. So practice that if this is challenging so that this becomes easier.